Welcome to clickmyproject.com. Now let me discuss about the extracting salient brain patterns for imaging based classification of neurodegenerative diseases. In this process, the neurodegenerative diseases comprise a wide variety of mental symptoms whose evaluation is not directly related to the visualized analysis. In our method, we are going to implement the kernel functions for future extraction to identify the neurodegenerative Alzheimer's diseases in the brain image. The automatic brain morphometry analysis that do perform this qualification contribute very little. Many of these methods classifies, they do not produce useful anatomy functional. Mainly, our paper presents a new fully automatic imaging analysis method that reveals discriminative brain patterns associated to the presence of neurodegenerative diseases. First, the input image has converted into gray image and processed by the saliency map image. After getting the saliency map image, we have to normalize. That means we have to change the intensity level to our processed saliency map and applying the kernel fusion for the future extraction of the images. After extracting the features of the images, finally by using the SVM classifier to classify the future values and identify anatomical regions. These processes are bottom-up and top-down information flows in the process. Bottom-up information comes from a multi-scale analysis for different image features, while the top-down stage includes learning for fusion strategies formulated as max margin multiple kernel optimization problems. The capacity of finding discriminative anatomical patterns was evaluated using the Alzheimer's diseases as in this paper. Finally, the anatomical analysis discriminant regions was found by our proposed algorithm. This is the flow diagram of our project, and here there are the two sections. The first one is the trained section and another one is the test section. So first we have to do the trained section because we have to train all images in the database, and after that we have to test by each and every image by using the test images by one. In both trained section and test section, the process are same. The only difference is in trained we have to train the whole database, but in test section we have to test by one images. And here we are using the kernel fusions for future extraction and using the SVM classifier to classify the images. Now let me see the process. First, the input brain image will be calculated by using the saliency maps. After the calculating the saliency map image, the image will be normalized by changing the intensity level. By using the normalized image, it will pass through the kernel fusions to extract the features. After getting the features, we will combine the both dataset features and the test features by using the SVM classifier, and the classifier will provide some labels due to the images. By using the label, we identify the anatomical interpretations. In the anatomical interpretations, the red regions are associated as the pathologies and the blue regions are associated as normality. So finally the performance analysis for our project. Now let me see the coding execution part. So open the main.m function file. So click on the run button. So this is our output window. First we have to load the input image. So click on the load image button. So go to the dataset folder. So here I am having 35 images. You can select any one of the images from the dataset. So I am choosing this one. So this is our input image and this is our input gray image. The next process is we want to getting the saliency map from the gray image. So click on the saliency map button. So this is our Salient map image. So next process is feature extraction. So click on the feature button. Before we get in the feature extraction, we have to normalize the Salient map. So we have to click the normalize button. So this is our normalized image. The next process is feature extraction. So click on the test feature button. This is our feature extraction values for our normalized image. So click on the next button. It will go for the next process. So next process is classification. So have to click the classification button. In classification, we are using the SVM classifier to classify the images. So click on the classifier button. So this is our output image. So click on the detail button. So the red regions are associated to the pathologies and blue regions are associated to the normality. So the diseases are the identified. So go to the next process. So click on the next button. So final process is our result. So click on the result button. This is a result analysis for our project. So next thing is graph. So click on the plot graph button. So this is a graph for our project. This is for balanced accuracy graph. The existing method we're using a VBM method and proposed method is kernel method. And this is the specificity graph for our project. And this is sensitivity of our project. And this is the accuracy graph for our project. If you want to exit, click on this exit button. Thank you.